Okay, taking a look at the problems that we were doing for reviewing. If we're looking at number 10, we have to simplify that question. What do I have to do with the number on the outside of the parentheses? Multiply or distribute with both of them inside. So my final answer would be 2b times b, which would be 2b squared plus 2b times 11, 22b. Okay, let's take a look at number 16. This problem, you had to find the greatest common factor. To do that, you can find out which numbers multiply together give you 8. And that would be 4 and 2. And 4 breaks down into 2 and 2. So my factors for 8w squared would be 2, 2, and 2, along with 2 w's. Then I need to factor out the 18w. 18w, what two numbers multiply together give me 18? 9 and 2. 9 can be broken down in 3 and 3. So my factors for 18 would be 2, 3, and another 3. I have a w, so I have to include the w with the factor. So now I can look at the numbers and see which ones are common. I have a 2 there and a 2 there. So the greatest common factor for the number is a 2. And then if I look at the w, I have a w there and a w there. I ran out of w's, so my greatest common factor is 2w. For the next problem, number 22, we have t squared plus 8t. If you look at this problem, there's an 8 right here, but this other number doesn't have a number. It has an invisible 1 there. And 1 isn't part of your greatest common factor, so this one right here is not going to have a number as a greatest common factor. So if I'm looking at t squared, there's no number, so how many t's do I have to write here? 2. So I'm going to write 1t and then another t. My other number, 8t, I don't have to worry about finding the factor for the 8 because there's not a number up top. I'm just going to write down the t that goes with that problem. So I'm looking for a greatest common factor. I have a t in both of them, so that's my greatest common factor. So now I'm going to have to take my original problem, t squared plus 8t, and then I'm going to have to do what with this greatest common factor of t? I'm going to have to divide it. I'm going to divide each one of these by t. Don't forget, when you find your greatest common factor, put that outside the parentheses. And since there's 2 numbers in this equation, you want to make sure you have 2 lines inside those parentheses. And so when I do that, since it's a plus, I know it's going to be a plus in the middle there. So I have a t squared right there. I have an invisible 1 right there. When I divide exponents, what do I do with them? Do I add or subtract them? Okay, I want to subtract them. So 2 minus 1 is just 1t. And over here, I have a t to the first, 1 minus 1, that becomes 0. So there's no t's left over. I'm just going to bring down the 8 from that problem. So I don't need the 1 there, so I can erase that 1. So my final answer is t, and then in parentheses, t plus 8. All right, let's take a look at the first problem, which was number 14. This problem here, I just wanted to simplify it, just like before. So I need to take that 8y to the third power and do what with it? It's 8y to the third power. What do I have to do with it? Multiply, distribute with every number there. So I'm going to take negative 8y to the third times 7. So I'm going to get negative 56. And what do I do with the exponents when I multiply? I add them, right? So I have y to the fifth power. Now I'm going to take negative 8 times negative 4y, and negative is a positive, good. And then I have 8 times 4, which is 32. So I'm going to take a look at the y. There's a divisible 1 right there. So again, what am I going to do with the exponents when I multiply? Add them, okay? So 3 plus 1 is y to the fourth power. And then again, I have here negative 8 times the negative 1. Negative is a positive. And then 8y to the third times 1 is just 8y to the third. So that's what I should have got for that problem. Okay, the next problem we had to do was question number 20. And this one, we wanted to find the greatest common factor. So this one here, greatest common factor. In order to do that, we can do the factor tree like we did before. But can you look at these numbers and find out what number multiplied together gives me 14? 7 and 2. 7 times 2 is 14. That's the smallest number, so I'm going to take a look at that number first. So take a bigger number of those factors. So does 7 go into 42? Yeah, 42 divided by 7 is 6. Does 7 go into 21? Yeah, 7 times 3 is 21. So right away, I know that 7 is the greatest common factor. If you don't know how to do it that way, because that's not a little bit harder to do, you can go ahead and factor the two numbers or all three numbers and then circle the ones that are common and do that. Okay? But here's a quick way of doing it by looking at all three numbers. Now take a look at the letters. You got a 4, a 3, and a 2. We know there's a z in each one of them, right? So we know the greatest common factor is a z, but what power? It's the smallest number of all three numbers. That gives you the greatest common factor. There's 2 z's here, there's 3, and there's 4, but each one has 2 z's. So then this is my greatest common factor. Now if I'm going to take a look at number 26. A long problem. Again, we're looking for the factoring. In this problem, you had the factor. Before I factor, I need to find what? The greatest common factor, the GCF, just like we did in that problem. So when I'm looking at that, if you look at each one of these numbers, each one has a G, right? Does each one have a number in it? Does this number right here have a number with it? No, it has a divisible 1, but that doesn't really count for a greatest common factor. All these other ones have a number. Just because this first one doesn't have a number, you're not going to have a number for the greatest common factor. But you guys found out it's not a number. But you did find out that the greatest common factor for this problem was a letter. And this one had 1G, this had 2, 3, and 4. So the greatest common factor is just G, because this one only has 1G. So once I find the greatest common factor, what do I have to do to each one of these numbers in the problem? I have to divide, right? So I'm going to take this original problem, and when I do it, remember, the greatest common factor goes on the outside of the parentheses. How many numbers are in my problem? 1, 2, 3, 4, so inside here, I'm going to put how many? 1, 2, 3, 4, and put my parentheses. If I look back at my numbers, all the problems have a plus sign. So I'll just add a plus sign in between. So now I'm going to take my greatest common factor and divide it with each of the numbers in the problem. So when I do that, I have g to the 4th power, and there's a 1g down here. So again, I'm going to subtract my exponents. So 4 minus 1, so 4 minus 1 gives me 3. So I'm going to put g to the 3rd power. Then I divide again. There's a 24, so I'm just going to put the 24 here in the problem. I know there's a g, and so it's 3 minus the 1 is 2. So it's g squared. Then I'm going to look at 12. There's not a number, so I know I'm going to put a 12 there. I have 2 g's up here, 1 on the bottom. What do I do with those two numbers? Subtract them. 2 minus 1 is just 1g. Now take a look over here, because this is where we ran our problem up on the board. The number's a 4, so I know the 4 is going to go there, but I have 1g there, 1g on the bottom. I subtract them, so 1 minus 1 is 0. So I'm not going to have any g's in this problem. So my final answer is, just like you had on the board, but you don't want to put a g in the back one, in the last one. Okay? Yes, I'm looking at number 20. And in the directions, it said greatest common factor. When we did this earlier, we found out that it is 7z squared. I just want to give you more practice on changing it to a factor problem. So what do I have to do with this problem? I have to take my greatest common factor and divide it with each one of these numbers down here below. So it's 7z squared, 7z squared, 7z squared. And when I'm doing my factoring, I want to make sure I put my greatest common factor on the outside of the parentheses. So when I do that, I'm going to take 14 divided by 7 is 2. And again, how many numbers am I going to have inside the parentheses? 1, you got 1, 2, 3. So inside here, 1, 2, 3, and my parentheses. There's a minus sign in the beginning, so we'll put a minus sign. And then the last one is a plus sign. Now in my z's here, I got a 4 minus 2, that's 2. So that becomes z squared. Okay, maybe write that a little bit better. So it should be 2z squared for the first one. Minus, dividing the other one. 42 divided by 7 is 6. And then what do I do with these exponents? I subtract them. So it's z to the 3rd power. So 3 minus 2 becomes 1z. I'm putting a line there so it doesn't look like a 2 for you. And then 21 divided by 7 is 3. What am I going to do with the exponents? 2 minus 2 is 0. So how many z's are there? 0. So all I need to do is just write the number. 21 divided by 7 is 3. So my final answer is going to be 7z squared. And then inside the parentheses, we have 2z squared minus 6z plus 3.